Is on similar polygons. All right, so at your tables, you guys have found these measurements, right? For the most part, you guys are still measuring, I can tell. And these measurements might be off a little bit because, you know, the human eye is only so good. So usually it's going to be off around a millimeter or so. So AB, so what did you guys get for figure 1? What length when you measured in millimeters? Let's go with this table here. So Isabella, your table. What do you have for figure 1 for AB? 30, do we agree with 30? Yeah, how about the next one, BC? So, Anvita, what'd you get? 2.1 centimeters? Well, what's that as millimeters? 21. Okay, and then CD? Yeah, Cam?
12.
12. DA? Maya, did you get DA? What'd you get for that?
30.
30? All right, and then figure 2. So, how about this back table, the table with all the boys? Figure 2, what'd you guys get for AB? 22. And how about BC? 15. CD? Was it tiny? All right, so what did you guys get for the angles? How about measure of angle A?
65.
60, 65, somewhere around there. Anybody have anything in between? We'll say 60. Did you guys get 60 for both of them?
Yes.
Yeah, so the angle measures are the same. What about angle B?
I got 86.
86, somewhere around there. Yep, good. How about C? 110? 110? Okay, and then the last one, did you get somewhere around like 104?
Yeah, I got 100.
Okay, so we'll say 104 to make that 86 nicer. All right, so the ratio for our angles, our ratio is just kind of like 1 to 1, right? But our side lengths do have a ratio. So if you do like 30 to 22, like I said, it's not going to be precise, but if I do like a decimal, I'd have 1.36. If I do 21 divided by 15, 1.4. 12 divided by something equals 1.4. Did you guys get like around, what did you get for this angle here? 17 for the, so that was our issue. Okay, 17, what did you guys get for figure 2? 11? 12. Oh, so maybe they were flipped. So we had 1.41 or 42, I guess. And then the next one? 30 and 22 again, so like 1.36. So notice how these aren't exactly right, but they should be in the same ratio. They should be around 1.4, right? 1 to 1.4. Basically, our sides are in the same proportion. So let's say it had been double. If this was twice as big, and I knew this was 10 and this is 5, then I would know if this was 8, this one had to be 4, right? Does that make sense? So we have everything in the same proportion. So if we know that we're just dividing by 1.4, we can get all those other ones. Okay, I know they're not perfect. That's why I said the human eye can only be so good. But our sides are definitely in a proportion, right? They're in the same ratio. And our angles are exactly the same, right? Just because we made a figure smaller. Think about squares, right? If I have a big square and a small square, this angle is the same as this angle. It's not like the other one, like double or something, right? It doesn't make sense for that to happen. Okay, so similar polygons. So two polygons such that their corresponding angles are congruent. And the lengths of the corresponding sides are in the same ratio. So the word we would use there is proportional. That's a weird quote there. Okay, and the symbol for similar to, do you guys remember this symbol? What's this symbol?
Congruent.
Congruent. It's not that one. Take off the equal part. That's similar to, okay? So it's going to be just that. And then sometimes we'll have those extended ratios, which we talked about, like when it says like 1 to 2 to 3, right? So an extended equation that relates all the equal ratios in a polygon. Okay, so if you have something like this, your statement of proportionality is going to look like xy over, what does xy match up with, guys? xy, vu. So xy divided by vu has to be the same as xz divided by what? So look, first letter, third letter? Yeah, so if I do xz, then I'm going to do vw, exactly. And then there's one more. So if I do, so I did xy, xz. I also want to do yz. What's it going to be? UW, exactly. And I can have any two of these to create a proportion. So I could do those two together, I could do these two together, and then I could do my cross multiplication to get whatever I'm missing. Make sense? All right, so in this case, it says write a statement of proportionality. So our statement of proportionality is going to be when we match up all of our different sides. It's going to be a little challenging on this one. There's a lot of sides. So we're going to say that A, B, C, D, E is similar to. What do you think A matches up with? Can you guys tell by the picture? If you think about rotating it and making it bigger.
W.
Yeah, it's W. So it's going to be W. What do we think? W, V, X, Y, Z. All right, and then we start matching those up. So we're like, okay, AB over WV. So this side and this side. And then we do BC over VX. Do you guys see what it is? BC over VX equals, and we have all of those. So we would need to write all of them down. I know this is like thrilling for you, but just keep going down the line. So AB, BC, BC, you know, and so on. So then we have CD and XY, and we have DE and YZ. How many sides should I have? 5. So last one is AE, right, to match it up there, or EA you could put, which is WZ. So just make sure if you have 5 sides, you have 5 fractions that equal to each other. Congruent angles. Angle A is congruent to angle W. Angle B is congruent to angle B, and you just go down the line. We'll say etc. All right, so next picture. So it says to decide if the quadrilaterals on the right are similar. If so, write a similarity statement and solve for A and B. All right, so if we're deciding on something similar, we want to make sure that they have all the same angles. Are all of the angles congruent in the two? Yeah, so angles are congruent. So we'll put a little check, done, angles are congruent. And then we want to check that the sides are in the same proportion. So sides, well, sides are in the same ratio. So let's check. So 12 looks like it would match up with 4. So we want it to be, it's kind of tricky. I didn't really tell you that the sides were in the same ratio, did I? So we want 7 to match up with what? Yeah, B. So we can solve for B and A. This is a little bit weird. I don't think this is a good problem. I'm going to skip this because I should have given you another measurement, I think. Because I want you to see that those sides are in the same proportion. So I think I wanted one of these to be like 7 over 3. No, not 7 over 3, 21. Let's make A 21. So then when we do 21 over 7, are we in the same ratio for the sides? Yeah. I don't necessarily know if all those other ratios. Well, we do know opposite sides are congruent. Or opposite angles, I mean, opposite angles are congruent. So what type of quadrilateral does this have to be? So this is a parallelogram, right? Let me just write parallelogram up here somewhere. Parallelogram. So then once we have that, we can say, oh, they're in the same ratio. So then B would have to be 21 then. Sorry, that's not a very good problem. All right, number 3. So in the diagram, measure of angle B and measure of angle F are the same. And they're both equal to 90 degrees. Decide if the quadrilaterals are similar. If so, write a similarity statement. So do we think that all of our angles are the same? So like D, does it match up with itself, D? Do you guys see the small quadrilateral and the big quadrilateral? Do those angles match up? Yeah. What about those other angles up in the corner? Like this one right here. What does it match up with? A. Do we think those are the same measurements? And if so, tell me why. Oh, geometry. You always have to tell why things are true. Don't you hate that? So rough. Not necessarily because they're not congruent. So he's saying CPCTC, that would be if you had congruent parts. Okay, so what we're going to look at is, you see this line right here? This line and this line. Tell me why you think that those are all parallel to each other. They look like they are, but are they indeed parallel to each other? Yeah, those right angles tell us that these lines are parallel, right? You can't have a right angle and be like, oh, this other one's a right angle, but it goes like that. That doesn't make sense, right? It has to be like this, which means our alternate, or not alternate, our consecutive interior angles, same side interior angles, are not only supplementary, but they're equal to each other. That makes these parallel. Do you guys understand what I'm saying? Okay, so if those are parallel, then why do we know this angle and this angle are the same? Because they're corresponding angles, right? So you kind of have to go through this thought process and be like, why are these the same? So yes, our angles are the same. So all of our corresponding angles are congruent. But does that necessarily make them similar? Not necessarily. Okay. Think about things where you have angles are the same. So a basic thing would be like this, a rectangle. These sides are the same, these sides are the same. That is not similar to a square. Do you understand what I'm saying? Okay, so just because the angles are the same doesn't mean that all the sides are in the same proportion. So we got to find something where our sides are in the same proportion. So we got to look. So we have this whole thing was, what is that, 10? This whole thing is 24. It matches up with the 10. Do you guys see how those are both the bases of those trapezoids? So we know those should be in the ratio. If they are in the same ratio, it's going to be 24 to 10. Do we have any other measurements that we can check? No. So I need to get rid of these, decide if the quadrilaterals are similar, because I didn't give you anything to show if they're similar. You need to see if the angles are, or if the sides are the same. So let's assume that they're similar, I guess. So then can we get all those different measurements, x, y, and z? Yeah, we can get those. So we're going to do, what would I need to do in order to find x? This side right here. It's going to be 15 over x. Do you guys see that? If I do big over small, I want to do big over small in the next one. So I'm going to have 24x equals 150. So I do 150 divided by 24. So I get x equals 6.25. What if I want to find y? So someone give me a new proportion. So a fraction equaling another fraction. Let's find y. Yeah, so you're saying 16 over y equals the big 24 over 10. So 24y equals 160. So we get y equals 6.6 repeating. And then the last one is z, right? So if I'm finding z, I'm going to do 12 over z equals 15 over, not 15, I could do 15 over x. But I'm going to do the 24 over 10 still. Use the nice numbers. The ones you had originally, that's always nice when you use original numbers instead of ones you found along the way. Where did I get the 150? I did this. Remember the cross multiplication. So I think I get z equals 5 here. So we have x, y, and z. Okay, do you guys see what I'm saying I did wrong in the notes? Like, I really shouldn't say decide if the quadrilaterals are similar unless I have, like, side lengths that I can check if they're all in the same proportion. I don't have all the different side lengths. I was trying to find the side lengths. So I should say something like, assume these quadrilaterals are similar, find x, y, and z. That's how my statement should read, okay? All right, so scale factor. So this is kind of what you guys are going to be doing with your poster. So it says the ratio of the lengths of the two corresponding sides of two similar polygons. So it says you've been asked to create a poster advertising a school field trip to the Indianapolis Zoo. So you have a photograph of the largest elephant, Sophie, and you want to enlarge this to poster size. So your photograph is 4 by 6 inches long, and you want the length, so you want this right here. You want to change it so that it's 20 inches long. So how wide will the, no, you would like the length, never mind. I guess I'm saying width and length. Let's call this the length. And width. Okay, so how wide will the poster be? Okay, so we're going to set it up and we're going to say the original thing is 4 over 6, where we have the width and the length. So our new one, we want to do width over length as well. So we want it to be width, we don't know, length is 20. Okay, everything's in inches. I always check that. I make sure that I don't have things in like inches and feet. Max, you with me? So we cross multiply. If you want to reduce first, some people like to do 2/3 equals W over 20. You can do that. You could reduce if you want to. Okay, so either way, so if we cross multiply, so we have 80 equals 6W. So if we take our 80 divided by 6, we get 13.3 repeating. So 13 1/3 inches. So it says, well, what is the scale factor? What do you guys think we would say for the scale factor of the picture to the poster? So the picture's original length was 6. We wanted the poster to be 20. Can we write that in a simpler way? Yeah, we can write that as 3 to 10, right? Let's write it like that. Could I go even smaller and do 1 to 3.33333? I could, but that's kind of weird, right? We try not to use fractions or decimals in our scale factor. It says, what are the perimeters of the photograph in the poster? Do you think the perimeters are also in that ratio? So this is something that you'll see a lot of questions, definitely on standardized tests, like the SAT will have questions like this. So are the perimeters of the photograph and poster, what are the perimeters of the two? So let's do the perimeter of the photo. Okay, so the perimeter of our photo is 4 plus 6 plus 4 plus 6. So we get 20. That was in inches, right? And the perimeter of the poster was, well, we saw one of the sides was 13.3 repeating, and one of the sides was 20, plus 13.3 repeating, plus 20. All right, so if I have 13.3 repeating, that's 13 2/3. The way I would put that in my calculator is 13 plus 2/3, or well, not 13 2/3, 26 2/3. Plus 20 plus 20, so plus 40. Yeah?
How do you know that like it's 13.3 repeating and not like 13.33?
Oh, like why do we say 0.3 repeating and not 33 repeating?
It could be like 3,000.
It could be 33 repeating, because 33, if you repeat 33, it would be 33, 33, 33.
Well, see, exactly. So, like, how do you know which one it is?
We just call it the more simplified one, 0.3 repeating. Yeah. Did you guys know that 0.9 repeating is equal to 1? Mind blown. Remind me and I'll show you a proof. Oh my God, a proof of that.
Oh, what do you do the box?
I don't know if there's a box or not. Yeah. All right. So is our perimeter of the photo to the poster? What is it? It's going to be 20 to 66.6 repeating. Okay, let's reduce that. So on your calculators, do 20 divided by 66.6666666, right? Do you guys know how to get 6 repeating on your calculator?
2 divided by 3.
Yeah, 2 divided by 3. 6 divided by 9. Same thing, 2 divided by 3. So if I have 66 plus 0.6 repeating, I go ahead and put that into my calculator first. And then I do 20 divided by that. This is the same as 3/10. Right? Isn't that weird? Yeah, it's the same. Try it on your calculator. 20 divided by, so here's what we're doing. 20 divided by 66 2/3 is what we're doing. That actually reduces to 3 over 10. So what I was saying is the 66 2/3, you can write that as an improper fraction if you want. What would I do if I was trying to change this into like where it was something over itself, or something over another number, I mean.
66 times 3.
Yeah. 66 times 3 plus 2, we get 200 over 3. And 200, or 20 divided by 200 over 3 ends up being 20 times 3 over 200, which is 60 over 200. It reduces down. 2 times 3 over 10. Hang on, over. So we end up getting, like the 20 and 200 make 10, so we get 3 over 10. Do you guys see how those are the same? So what I was saying, the easiest way to do this is on your calculator. If you do 20 divided by 66.6 repeating, you get 0.3. What is 0.3? It's 3/10, right? Same thing. So is that the same scale factor as the original? we'll look at our original scale factor of the photo, 3 to 10. What about area? Predictions, 3 to 10. It's not. I know, mind blown. It's not. So let's think about why it's not. So now our area, so if you go through and you find the area of the poster, or of the photo, and the area of the poster, so the area of the photo is going to be 4 times 6, which is 24, and the area of the poster is going to be 20 by 13.3 repeating. So in your calculator, I would do 1/3 for the 0.3 repeating, plus 13. So I have 13.3 repeating. And then I'm going to multiply by 20. I get 266.6 repeating. Okay, if I want their scale factor, guys, I do this divided by this. Do it. Do 24 divided by that answer. These are in the scale factor. I got the number 0.09 on my calculator. Read that. You guys learn how to read numbers in elementary school and nobody like puts it together that these are fractions. How do I read that in elementary school? I say 9/100ths, right? 9/100ths. And what that means is 9/100ths, right? That's what that fraction is. You can hit math 1 if you're not sure and change it to a fraction. 9/100. Is this the same scale factor? So 9 to 100.
Wait, can you explain how you got that again?
I took this number divided by that number.
Well, like on your calculator, how do you see that it's 9?
Oh, if you hit math 1. So did you get the 0.09 part? No. Okay, so do 24. Well, let's do the 266.6 repeating first. So do 2/3 first, right? Plus 266. You got that. Now do 24 divided by answer. Did you do that? Pretty sure. So you should get 0.09. And 0.09 as a fraction is 9/100ths. 9/100ths, right, is how we read it. Now do math 1 and we'll change it into 9/100ths. Okay, who sees the relationship? Cam, you with me?
Yeah, I am.
3/10. For area, or for perimeter, it was the same. It was 3 to 10. For this one, what happened? It squared. So for area, I went into squares. That comes from this. Inches squared, inches squared. It's telling us that I don't have inches like the original problem. I now am squaring my inches. All right, that was kind of a I should have given you nicer numbers. Here, guys, let's look at this.
So if you need to find the area, can you just square the 310 and see what it is?
Yeah.
Wow.
So if I have something that's 2 by 5, a rectangle, and I look at something that's 4 by 10. Okay, guys, look. This is in a ratio of 1 to 2. Do you guys see that? The perimeter of this one is 10 plus 4. It's 14. The perimeter of this one is 28. Do you guys see those are still in the ratio of 1 to 2? So the sides are in a ratio of 1 to 2. The perimeter is in a ratio of 1 to 2. What's our prediction for the area? Yeah, because this area is now 2 times 5, which is 10. And this area is now 4 times 10, which is 40. Do you guys see how this is in a ratio of 1 to 4? Okay. Think about it this way. 1, 1, 1, 1. A 1 by 1 square. A 2 by 2 square, right? If all these were 1, 1, 1, 1, 1, 1, 1. Look at the area. The area of the first one's one of these units. But if I double both the length and the width, right, you guys see how I'm doubling 2 dimensions? The length becomes 2, the width becomes 2. What happens to the inside part? It becomes 4, right? Does that make sense? Do you see what's happening here? If you double both the length and the width, then you now quadruple the area. But did we change our perimeter? Our perimeter just became from 1 plus 1 plus 1. Our perimeter was 4 originally. What's the perimeter of the next one? 2 plus 2 plus 2 plus 2. It's 8, right? It didn't quadruple. It just doubled. All right, so that's what we have here. So it says if two polygons are similar and their side length is in the ratio of x to y, their perimeters are also in x to y. This is supposed to be in that square too. It got left off. But if their areas, So if the originals are in the ratio of x to y, then their areas are in x squared to y squared. Okay, and that's where I said, think about if you have a 1 by 1, a 2 by 2, and a 3 by 3. What's happening to the areas? Do you guys see how I'm going from an area of 1 to an area of 4 to an area of 9? These were originally in the ratio of 1 to 2 to 3. See how we squared each of those? That's what's happening. Okay, so the following similar polygons have a scale factor of 7 to 10. What is the perimeter of polygon 2? So this is what I was telling you. Sometimes these will pop up on things like standardized tests. Okay, because the long way that people will do this, if they don't understand the math behind it, is they will find every single one of these sides, and they're not going to be pretty. Do you guys see what I'm saying? Like you would set it up 7 over 10 equals 8 over x, and you would find x, and then you do it from the next one, you do it 4 times. Okay, we don't want to do that. We want to make it easier. So someone tell me what we're going to do. Add them all up, get our perimeter, right? So 8 plus 6.5 plus 7 plus 6. So we have 27.5. So then if I want to go to the perimeter of polygon 2, I say, well, my polygon 1 was 27.5. My polygon 2, I don't know. But I do know that they're in the ratio of 7 to 10. Do I keep it as 7 over 10, or do I square it and make it 49 over 100? I keep it. Perimeter, I keep it, right? They have the same units. It's just inches, not inches squared, right? All right, so as I cross multiply, I get 275 equals 7x. So I get x is equal to 39.286. That is going to be my perimeter of polygon. Do you guys understand this process? All right, so this picture. So it says the figures in each pair are similar. Compare the first figure to the second figure. Give the ratio of the perimeters and the ratio of the areas. So I want you guys to think about it. So think about questions 2, 3, 4, and 5. So talk to your tables. Come up with a solution. All right, so the first one, you guys, as I was walking around, I saw that you guys, whoops, had 14 to 21, and you reduced it, which I think is good. So if you have 14 to 21, that reduces, divide by 7, you get 2 to 3.
Okay.
So the perimeter should also be in the ratio of 2 to 3, and the areas should be in the ratio of 4 to 9. Did you guys get that? So you don't have to actually find each side length. All you need to do is say what ratio the sides are in. Okay, so number 3, they were in a ratio of 16 to 12. Again, if you reduce, so divide by 4, we have 4 to 3. So that means the big over the small is in 4 to 3. So the big over the small needs to not be in 4 to 3 if we're talking about area. What do we need to be? We need to square these, right? So we need 16 over 9 is the same as 105 over x. Did you guys catch that?
Yeah.
Okay, so as we cross multiply and divide, what did you guys get for x? 59.0625. Okay. The next one, we're going to do the same thing, but now we have the area of the smaller one. So be careful. So we're going to do our 13 over 5. We really just need to square both sides, right? So that's going to be 169 over 25. That 169 over 25 is equal to, where do I put the 65? On the bottom, right? So if I do like big over small, then I want to make sure I do big over small in the next one. So I'm going to put 65 on the bottom, put x on top. So we get 169 times 65 divided by 25. So we get 439.4. Did you guys get that? Units? Meters. Area? Squared. So last one, units. Number 2. Oh, I didn't ask for that one, did I? This one. This should be feet squared. Yeah. All right, and then the last one, a little tricky. So it says it costs the family $216 to have a 9-foot by 12-foot wooden floor refinished. At that rate, what would it cost them to have a 12-foot by 16-foot wooden floor refinished? Okay? So let's think about it. So what is the area that we have here? 108 feet squared, right? What is the area of the other one? So it was 16 by 12, right? So if we do 16 by 12, did you guys get that number? 192? These areas are in a certain ratio. Okay? So if it costs a total of 216 to replace this one, we want to know how much it's costing for the other one. Do you guys see how our feet squareds are going away? Okay, this last unit, x, is going to be in dollars because we want our dollars to go away as well. Okay, so we don't really need to square things here because we've already taken care of the squaring when we did the feet by feet. So we're going to do the 108 divided by 192. Well, actually, let me cross multiply. 192 times 216. And then divide by 108. What'd you guys get? Yeah, $384, right? Does that make sense? Do you guys get it? Okay. All right. So let's stop there. You guys can go on your break.